Hello, and welcome to part one of the beam flexure test. This is the steel beam that we're doing here in our Strength and Materials lab. You need to make sure that you have a clean notebook sheet of paper, if you have a lab notebook, so that you can record test data and measurements that you actually have to take during the laboratory today. All right, so here's our setup. We have a steel beam. It's actually fixed at the left end, and there's a strain gauge you can see here attached to the top that will measure axial strain. The fixity, the shift's a little off. You have to decide where you're going to use to measure the length there on that left end. And here on the right end, we've drilled some holes and there's a chain hanging off, and that's where the load is actually going to be applied. And so it's also important for you to determine what is the length of the beam as far as where the point load is placed. All right, so our strain gauge, you can see the center line of it there is marked with a pencil, and that's what you're going to measure to, and we're going to use a straight inch ruler to do our measurements. And we can see on this ruler, instead of having 1/4 of an inch, 1/8 of an inch, etc., it's actually broken into tenths to make your life a little bit easier. So the top, every tick is 1/10 of an inch, and on the bottom, actually, there are 10 ticks between each of the intermediate ticks, giving us 100 ticks between 1 and 2 inches. So you can use either one of those to do your measuring. And so we'll initially measure from the bottom, and so you can pause the video now and get your measurement for the strain gauge, and then you can pause it again and figure out what your measurement is for the end of the beam. And then we will do this again, measuring on the top, and so you can pause the video and measure where the strain gauge is at. And then we'll now, at the free end of the beam, you can determine what you want to use as your length. Again, if you need to, pause the video to take your measurement. Once we have our length information, we need our width. So typically you want to take multiple measurements and average them. And note on this tool, you only get accuracy in 4 digits. That last little 5 that pops up and down, not really an accurate number. So here's our 3rd reading, and we'll go ahead and take a 4th reading, and you can average those and just report your average. For the thickness, unfortunately, I lost some of the video, so I only have 2 measurements with that 0.120 inches and now 0.119, 0.120 value there for our thickness. All right. So now we're ready to run our test. So we're going to have these weights that are hanging off of here, and you can see we have 158.32 grams, 158.36 grams, and then 153.7 grams. And also we've now added, and we saw this just a second ago in the video too, we've added this extensometer, and the extensometer is going to measure how much the beam is deflecting or sagging at the point of load application. So you could see just a second ago that it's placed right where the chain is at. And then we have up on the computer screen that's now inset there in your upper left corner, the green is measuring the strain gauge, the normal strain that we'll experience. So here we're putting on the 158.32 grams, and we see we have 0.0108 inches, and it's negative, and we're at about 19 microns. So we're getting our strain in microns, right? 158.36 grams. And did our strain and deformation jump literally? So go ahead and record those amounts. Remember, the strain is microns, so the real value is times 10 to the minus 6. You can see those are negative. All right, now 157.64 grams, our last value. Again, take your readings. Call it 0.0360 negative inches. And now, because we would expect linear elastic behavior, let's go ahead and unload this and just take note as we take these weights off. Are we going back to basically where we were at before? Are we seeing a linear relationship that when we load and unload, we get the same values? And we would hope that we get back to 0 when we take this last load off. The extensometer might be a wee bit off because sometimes you get friction between the extending shaft and the extensometer, and so it might not perfectly go back to 0. All right, that's it. That's the steel beam test. So this ends the experiment. And now you can head off and complete the aluminum beam before you do your calculations. Thanks for watching.